So before we start, I request everyone to please mark your presence. Please be quick and mark your presence. Okay, so let's start with the concept. So first of all, we all need to understand that any number, right, which we call dividend, can be written as product of divisor and quotient. When we talk about factor of a number, then in that case, please always keep in mind that both divisor and the quotient are going to be factors of the given number, right, which we call dividend. Now on the other side, when there is any number n, it can always be expressed as a product of two factors, which I am writing as a and b. So please always keep in mind that both a and b are going to be factors of the given number, right? Okay, so just give me a sec. So when we talk about a number like 6, 6 can be written as either 1 into 6 or 2 into 3, which means 1, 2, 3 and 6, all these values are factors of 6. So whenever we have to write a number as a product of two factors, always start with 1 and the number itself. So this value keeps on increasing and this value keeps on decreasing. And all the factors are always going to be in between 1 and 6 only. So when 6 is considered. So when we consider 8, all the factors of 8 are going to be 1 and 8 and rest of the values will be between 1 and 8. So we can write 8 as 1 into 8 or 2 into 4. They are the only two possibilities. Likewise, 9 can be written as either 1 into 9 or 3 into 3. Please always keep in mind, if there is any number which is a perfect square, in that case we will always come across a case wherein both the values are same, right? So 9 will be having three factors, 1, 3 and 9, so do not count this value twice. In case of 12, it can be either 1 into 12 or 2 into 6 or 3 into 4. In case of 36, which is again a perfect square, we will find a case wherein both the values are same, right? By writing the given number as a product of two factors, we can always write down each and every factor of the given number. But that thing is feasible if and only if the given number is small enough and I can write all the factors easily. But if the number is very large, which may have 100, 200, 300 factors, then this concept will fail. But it is very much required to understand how to write down all the factors of the given number if the number is small. Based on this concept only, there was a question this year given to me, n was 4 raised to power 2017. And the question says, in how many ways n can be written as a product of a and b such that a is less than equal to b. So the very first thing required here was this 4 can be written as 2 raised to power 2 whole raised to power 2017, which further can be written as 2 raised to power 4034. Now the power is even, it is a perfect square. So we need to observe these two cases to find our answer quickly. Right, so in case of 9, the number of ways in which 9 can be written as a product of two factors is 2. In case of 36, the total number of ways comes out to be 5. And the number of factors of 9 are 3 in number. Number of factors of 36 are 9 in number. Now guys, can I say this 2 can be achieved by saying 3 plus 1 by 2? Or in this case, this 5 can be achieved by saying 9 plus 1 by 2 is 5. So likewise, in this case, number of factors are always 1 more than the power when this number is a prime number. Alright, so we can say that the number of factors are 4035 and the number of required pairs will be plus 1 divided by 2. So which comes out to be 2018, which was the required answer in the paper. So very easy question based on the concept of factors came in exam this year. So guys, please check it out. I hope this much of part is clear before we proceed with the concept of factors. So this is a very minimalistic approach for solving questions based on factors. Right? Okay, so let's move on. Now, in general, if n is written as product of powers of prime numbers, so this is also called factorized form of the number. So whenever we say that we need to factorize the given number, please always keep in mind that we need to express the number as a product of powers of prime numbers only. So here the powers should be of prime numbers. Please keep that in mind. Right, so this is a very basic term that we keep on using again and again, and everyone must adhere to the same. So when the given number is in factorized form, we just need to think of, if I am required total number of factors, what all values which are the powers of P1 or P2 or P3 can divide the given number. So can I say the powers of P1 that can divide the number will start with 0 and end with A. The powers of B, P2 raised to power B will start from 0 and will end with B. Likewise in case of P3 raised to power C. Now from 0 to A, the number of values in this column are A plus 1. The number of values in this column are B plus 1. The number of values in this column from 0 to C are C plus 1. So when we have to generate a factor, we need to select a value from this column, which should be multiplied with a value of second column, and then with all the values of third column. And likewise, we start getting all the factors of the given number n. So the number of factors finally result in the product of A plus 1, B plus 1 and C plus 1. If we observe it closely, we can straightway say that here if your power is A, B and C, we just need to add 1 to the power of the prime number and multiply all the values. It will straightway give me total number of factors of the given number. Here the reasoning is very important, why we are getting A plus 1 into B plus 1 into C plus 1. I hope this reasoning is clear to each and every student. Okay, so let's move on. So here the given number is, find the total number of factors of 2 cube into 4 raised to power 4. So the very first step required here is, we need to convert 4 raised to power 4 to the power of a prime number, which is 2, because 4 is a composite number, not prime. So it becomes 2 raised to power 3 into 2 raised to power 8, which can be further written as 2 raised to power 11. So the number of factors of this number are 1 more than power 11 plus 1, answer comes out to be 12. Likewise, we are given a number 888 written 6 times. We are required factors of this number. So the very first step is factorizing the number. So if I take out 8 separately, it can be rewritten as 8 into 111 written 6 times. Now this number can be factorized as 111 into 1001. And now 8 can be written as 2 cube. 111 can be written as 3 into 37. And the factorized form of 1001 is 7 into 11 into 13. Now in order to calculate the number of factors, we just need to add 1 to the power and multiply them. So 3 plus 1 is 4, 1 plus 1 is 2. Because of all these 1s, we are getting all these 2s. Right? So we just need to multiply all the values. So the number of factors of the given number came out to be 128. So guys, please check it out. I hope it is clear. So the only thing that you need to keep in mind is, other than proof, factorize the given number. If there is a number which is having same prime base then collate their powers, right? So finally, once you are having all the values in the power of 2, we can find the total number of factors by adding 1 to it. Or if there is a number something like this, we need to prime factorize it. That is very much required. Once the number gets divided into the product of powers of prime numbers, add 1 to the power and then multiply all these values. So they are the only steps we need to take to find total number of factors of the given number. Now let's have a look here. How many numbers from 1 to 100 have exactly one factor? So please always keep in mind 1 is the only number. 1 is the only number which has exactly one factor. Now if we are being asked how many numbers from 1 to 100 have exactly two factors, please always keep in mind prime numbers are the only numbers which has exactly two factors. Alright, so in this case the counting will start from 2, 3, 5, 7, 11, 13, so on up to goes up to 97. So the total number of prime numbers from 1 to 100 are 25 in number. Likewise, when we are required, how many numbers from 1 to 100 have exactly 3 factors? Now please keep in mind exactly 3 factors will be obtained whenever the given number is a square of prime number. So if the given number is a square of prime number, which means it should be of the form p square. So 2 square, 3 square, 5 square, 7 square, 11 square, 13 square, all these are the numbers which will give me exactly 3 factors. But we are required numbers up to 100 only, so my count will stop at 7 square. So these are the only 4 numbers from 1 to 100 who has exactly 3 factors. So guys, please check it out. I hope all 3 questions are clear to you. So they are very, very, very important observations, and you can see these questions coming directly in the exam, right, in one or the other form. So they have already appeared in the exam. So it's very important for each one of us to understand that what all values are in these kind of cases. Now let's say if question says if n equal 2 cube into 3 raised to power 4, then in how many ways n can be expressed as a product of two numbers? As we did in the first go, right, on the very first slide we discussed it. Now let's generalize this thing. If a given number is, let's say, p1 raised to power a into p2 raised to power b, right? So the number of ways in which given number can be expressed as a product of two numbers will be equivalent to half of total number of factors. But that can be done if and only if total number of factors are even. In any case, if total number of factors are odd, then desired result will be either plus 1 upon 2 or it will be minus 1 upon 2. So in order to explain all 3 cases, I have taken 4 examples here, 3 examples here. So in this example, the number of factors comes out to be 4 into 5 because I am adding 1 to the power, which are 20. So the desired number of pairs will be half of 20, which comes out to be 10 in number. Now in this case, number of factors are 5 into 5, which are 25. In this case again, number of factors comes out to be 25. Now we need to understand the difference between the 2 questions which are being asked. So in this question it says in how many ways n can be expressed as a product of 2 numbers. But here he says n can be expressed as a product of 2 distinct numbers. So I am taking you back to the first slide. So here we were discussing whenever the given number is a perfect square, we will get a scenario like this wherein both the values are same, right? So in question number 5, he is asking that we can consider this case, but in question number 6 he says we cannot consider this case. That is the only reason we are getting variation here because of +1 and -1. So here the answer comes out to be 25 plus 1 by 2, which are a total of 13 pairs. So here I will be getting 1 pair less. So 24 by 2 comes out to be a total of 12 pairs. I hope it is clear to each and every student. Okay. Let's have a look at few more questions. So here it says n equals 2 cube into 3 raised to power 4, m equals 2 square into 3 into 5. Then find the number of factors of n that are common with the factors of m. So the factors of these two should be common. The power of 2 here is 3, the power of 2 there is 2. The only common part between the powers of 2 is 2 square. The power of 3 here is 4, the power of 3 here is only 1. So the power of 3 that is common among both is 1. So the power of 5 is not common between them, so I cannot take any power of 5. So can I say only those factors will be common among them which are the factors of 2 square and 3. It is nothing but effectively the HCF of m and n. All the factors of their HCF will be common between both of them. So the number of factors comes out to be 3 into 2 because I am adding 1 to the power 2 plus 1 is 3, 1 plus 1 is 2. So the correct answer comes out to be 6. So guys, please check it out. I hope it is clear. Okay. Here he says how many factors of this number are even. In order to calculate the total number of factors which are even, again we need to first of all express the number in the powers of prime numbers. So 4 is 2 square, which gives me 2 raised to power 10. 5 will remain the same. 6 is 2 into 3. It will give me 2 cube into 3 cube. Now 10 plus 3, the power of 2 comes out to be 13 into 5 raised to power 4 into 3 raised to power 3. The powers of 2 that can divide this number start from 0, 1, so on up to 13. The powers of 5 that can divide this number starts from 0 and at 4, and likewise the powers of 3 start at 1 ends at 3. In order to generate a factor which is even, we must multiply at least 2 raised to power 1. So out of this column, the number of values that will give us an even factor start from 1 to 13, which are 13 in number, which when multiplied with any of these 5 values, then any of these 4 values will always result in a even factor. So 5 into 4 is 20 and 20 into 13 comes out to be 260. So the correct answer option will be B. And 30 says, how many of the following statements are always true? Statement 1 says only squares of prime numbers have 3 factors. So that we have already discussed when we were doing that what all numbers have exactly 3 factors. So they are only and only squares of prime numbers, which means statement 1 is definitely true. In second, it says if a number has 4 factors, then the number must be a perfect cube. Now let's observe this particular case, how we can generate 4 factors. Now 4 can be a result when there is a prime number whose power is 3. So 3 plus 1 is 4. Definitely when the number is a perfect cube, we will get 4 factors. But this 4 can also be written as 2 into 2. Which means if there is a product of 2 prime numbers, when the power of both of them is 1 and 1, it will again generate 2 into 2, 4 factors. So if I say if a number has 4 factors, the number must be a perfect cube, this statement goes wrong. It can also be a product of 2 prime numbers. Let's observe 3 now. If a number has 5 factors, the number must be a fourth power of natural number. Now, when it comes to 5, 5 in itself is a prime number. So 5 factors can be generated if and only if the given number is the fourth power of a prime number, right? But he says it should be a fourth power of a natural number, right? Which again goes wrong. So the only correct statement comes out to be 1. So the right answer option will be B. So guys, please check it out. I hope it is clear. So please keep in mind, in third, he has mentioned it is the fourth power of a natural number, which is not possible. Is that done, guys? If any student has a doubt in this question, please do let me know. It is a very, very, very important question. Okay, so let's move on. So in fourth, it says how many factors of the given number are perfect squares but not perfect cubes. Again, the very first step will be to write the number as product of powers of prime numbers. So it is 2 raised to power 13, 3 cube and 5 raised to power 4. So we are required number of factors which are perfect square but not perfect cube. So when I say a number is a perfect square, so it should be of the form x square. If it is perfect cube, it should be of the form y cube. A number which is a perfect square as well as a perfect cube will be of the form z raised to power 2 multiplied by 3, which is 6. So effectively what the question is saying, we are required perfect squares, but power should not be a multiple of 6. Alright. So if we observe the given numbers, so here we can take 2 raised to power 0, 2 square, 2 raised to power 4, 6, 8, 10 and 12. All these values are perfect squares. So the power of 3 that we can consider is 0 and 2. The power of 5 that we can consider is 0, 2 and 4. So 1, 2, 3, 4, 5, 6, 7, 8, not 7, into 2 values, into 3 values gives me all the numbers which are perfect square. So we need to subtract all those which are perfect cubes as well among these. So it includes 2 raised to power 0, 2 raised to power 6, 2 raised to power 12. Here the only power of 3, 0, the only power of 5, 0 will give me a power which is a multiple of 6. So we need to subtract these 3 into 1 values out of the given case. So 7 into 6 is 42 minus 3. The correct answer comes out to be 39, which is answer option D. So guys, please check it out. If any student has any confusion or doubt in this, please let me know. I hope it is clear to each and every student. Okay. So in 50 says, what is the smallest number that can have 24 factors? So as we have discussed earlier, that total number of factors in general can be written as a plus 1 into b plus 1 into c plus 1 into d plus 1 and so on, where a, b, c, d are the powers of prime bases that are given to me. So if I am required 24 factors, we need to think of how we can generate 24 factors. So it can be a prime number raised to power 23, which will give me 24 factors. Or we need to write 24 as a product of two numbers. So 1 into 24 we have already considered. It can be 2 into 12, or it can be 3 into 8, or it can be 4 into 6. Which means using this we can say it can be product of two prime numbers wherein power of one of the prime number is 1 and power of other prime number is 11. Because 2 into 12 becomes 24. Please keep in mind they represent the values of a plus 1 and b plus 1. So if it is 3 into 8, the result can be out of p1 square into p2 raised to power 7. If it is 4 into 5, it can be the result of P1 cube into P2 raised to power 5, right? And if I write 24 as a product of three numbers, so if I separate this 24, it is effectively 2 into 2 into 2 into 3. Alright, so if I consider one of the value to be 1, and we need to write other two values as 1 into 24, alright, or again 1 into 2 into 12. So those cases will not give me any new value. All these values will again come into picture here. To get new set of values, I must take one of the value to be 2, and then it becomes product of 1 and 12, or product of 2 and 6, or product of 3 and 4. Or can I say, instead of considering 2 here, if I take 3, leftover value is 8. 8 can be written as 3 into 1 into 8, or 3 into 2 into 4. And we also need to check simultaneously whether we are getting same cases or new cases. 2 into 1 into 12 is as good as 2 into 12, so it's not a new case. 3 into 1 into 8 is as good as 3 into 8. It is again not a new case. 2 into 3 into 4 is similar to 3 into 2 into 4 goes out. So they are the two new cases that we are getting when we wrote 24 as a product of three numbers. So if I consider 2 into 2 into 6, it means given number will be a product of three prime numbers, and the powers of two prime numbers will be 1 and 1, and of third one will be 5. If it is 2 into 3 into 4, again it will be product of three prime numbers, and you just need to reduce the powers by 1. 1, 2 and 3 are the required values. And when you write 24 as a product of four values, this is the only way in which it can be written, and it comes out to be P1 into P2 into P3 into P4 square. As we are required the smallest number that can have 24 factors. So guys, can I say that in this case we must use smallest prime numbers to get 24 factors? So like if there is only one prime number, p raised to power 23, the number should be used is 2, so it should be 2 raised to power 23. If I use 3 raised to power 23, number will be even larger. In this case, we are required to use two prime numbers, so the power 11 should be with smaller prime number, and that it should be into 3 raised to power 1. Here it should be 2 raised to power 7 into 3 square, 2 raised to power 5 into 3 cube. Here it should be 2 raised to power 5 into 3 into 5, or 2 cube into 3 square into 5, and in this case it should be 2 square into 3 into 5 into 7. Now by comparing them, we need to observe which one is the smallest number. So 4 into 3, 12 into 5, 60 into 7 comes out to be 420. Right? So if I take 2 raised to power 23, it will be more than, you can say like in thousands goes out, because 2 raised to power 10 is only 1024. Alright. So 2 raised to power 11 is again a very large number. 2 raised to power 7 is 128 multiplied by 9. My answer again will be in thousands goes out, because this is a comparison figure which we must take care of. 2 raised to power 5 is 32 multiplied by 3 cube, which is 27. So again the value comes closer to 900, so leave it. So 2 raised to power 5 is 32 multiplied by 15. So 15 into 30 is 450, which is more than 420, so leave it. Now it comes out to be 2 into 5 is 10, 4 into 9, 36 into 10 is 360. So comparing all the cases, the least value comes out to be 360. So the correct answer option is C. Now this is the entire theory when the question is theta based, because in CAT we will come with either like options, or we will come with a case wherein we are having theta based question, right, wherein there is no answer option, we have to type in the answer. So this entire theory and solution is required if and only if it is a theta based question. But if the question is having answer options, then we must only and only observe the answer options. That's it. As he is talking about smallest number, always start with the smallest number, which is 360 in this case, and prime factorize the given number. So 360 comes out to be 2 cube into 3 square into 5 raised to power 1. Calculate the total number of factors, 4 into 3 into 2. Answer comes out to be 24 straightways. Because all conditions are taken care of, so the correct answer will be 360. So I am giving you the theory part. If and only if it is a theta based question, we must know how to solve it. Right? So guys, please check it out. I hope it is clear to each and every student. Okay. So there are a lot of questions that we can always discuss based on this concept. All right. So I am going to skip few questions for you, which we'll be doing later on in our regular classes as well. All right. So it will give you a very clear-cut picture about the topic of factors, how easy the chapter is. Now, please keep in mind, Gradeup community is always there to help you. Stay updated with all major announcements for all MBA exams. Daily free quizzes and mini mocks are given to you on a regular basis for more and more practice, and it also ensures that you never leave touch with the chapter of, let's say, quant or LRDI or verbal ability. Now, through Gradeup community, you can also engage with other MBA aspirants and stay motivated. A very important announcement, XAT 2021 exam analysis is planned on 3rd January 2021, which is a Sunday. It will be a live exam analysis and question discussion right after you are done with your exam. So your exam will be over by 12:30, and please keep in mind you have to come online by 12:45 to understand the expected cutoff of the exam and overall difficulty level. All right. So if you still have not subscribed to our channel, please subscribe to Gradeup channel and stay tuned to Gradeup app. So we will keep giving you push notifications so that you do not miss any analysis, you do not miss any discussion that is going on. Other important series for XAT 2021. So how to attempt XAT quantitative ability section. So learn from the topper, right, which you can do in 5 days. Crack arithmetic in 4 sessions. DI, decision making, boost your score in 5 days. And for verbal also, how you can boost your score in 5 days. So whatever mistakes you have done in CAT exam, right, so you need to work on each and every mistake thoroughly, which should not be happening again in XAT. Other important courses for 2020, Mission MBA, wherein all exams IFT, TestNet, CMAT, MAT, Maharashtra CT is also covered. For XAT 2021, decision making course, GK and current affair course is going on. Students who are clear about that they will be getting a call must subscribe or enroll for GD, VAT and PI program. It's a special course focusing on the requirement of each and every individual. Now, Gradeup has also introduced installment payment scheme. So now you can pay your 12-month fee in 3 installments or 18-month fee in 4 installments. Please keep in mind, students who want to pay entire fee in one go can also do still the same. You can pay your entire fee in one go, or if you want to take assistance in installments, you can always take 3 or 4 installments depending on the plan you are choosing. Here is the team who will be helping you out throughout your CAT journey. Pranav, Jatin, Vikas, Vijay, Ashish, Savitri, Sanojam, Anant, Ajay, it's me, Tapesh, Vikrant, Saral, Anurag. So among us, we six are 100 percentilers. So Pranav Pant is a 100 percentiler in DILR. Anant is a 100 percentiler in quant. I am 100 percentiler in quant and DI. Tapesh is a 100 percentiler in quant. Vikrant is a 100 percentiler in BARC. Saral is 100 percentiler in quant and LRDI. All other faculty members are 99.995 plus percentilers, right, who are also among the toppers turned faculty members. So we all wish you very best. Please keep practicing topic wise quizzes. Keep attending all live classes. If any student has any doubt, please let me know. Okay, so it's good. So I hope I have addressed all your queries. So thank you guys. Thanks a lot. Thank you. Thank you.